Hi everyone, and welcome back to the Enclosure Institute. I'm still Phil Taylor.
And I'm Jimmy Budd. In our last video, we talked about some of the material-related reasons why seals might fail. Today, we're going to continue that discussion, but talk about why a seal might fail related to part design, geometry, and placement issues. So let's dive in. The first geometry-related problem we'll discuss is when the sealing surface is too narrow. If the gasket is taller, that is thicker, than it is wide, it may collapse and distort in compression. We recommend a width to thickness ratio be at the minimum 1:1. We'd like to see it more like 1.5:1 or even more. In other words, we'd like to see the sealing surface of the gasket be 1.5 times wider than the gasket is thick. In most gasket applications, this should provide the gasket enough surface to seal against most pressures.
Another geometry problem we run into happens when the bolt holes or stress points of the fastening or compression are within the sealing surface, reducing the surface area of the gasket at those locations. We recommend that whenever possible, the bolt holes be adjacent to but outside of the primary sealing surface.
90-degree sharp corners can also cause trouble. After die cutting, these sharp corners in the foam often provide a stress point for a break or a tear. Use radiused corners whenever possible.
The last geometry issue we'll discuss has to do with gaskets that are composed of multiple pieces. The joints in the gasket that is designed in multiple parts can create leak paths. The motivation to make a gasket of multiple parts is most often done for large gaskets, such as door gaskets on large enclosures, when the cost of a continuous gasket without joints is prohibitive. As far as solutions go, I'd first say that whenever possible and affordable, design with one-piece gaskets. Of course, that's easy for me to say. But when that's impractical, you might consider what we call a collapsible gasket that must be carefully opened and installed, which can lead to its own problems, as we'll discuss in a few minutes. Another solution might be what we call a puzzle gasket, where the joints of the gasket parts fit together like puzzle pieces. Any way you cut it, see what I did there, Jimmy? When a gasket is composed of independent parts, the integrity of the seal is dependent upon the proper installation of those parts.
Another problem we see occasionally has to do with the position, integration, and placement retention of the gasket. Gaskets that are not accurately installed or securely retained can shift out of place, leading to leaks, uneven compression, and premature failure. This is especially true in high vibration environments, dynamic sealing applications, and enclosures exposed to pressure changes. To protect against these types of problems, you might incorporate mechanical compression hard stops to ensure consistent gap control. You might also add retention grooves to maintain gasket placement and alignment during operation.
On a similar note, during assembly of the enclosure, the placement of the gaskets in the assembly can be problematic. And improper handling, such as stretching, misalignment, or contact with sharp edges, can also lead to premature failure of the gasket. Care should be taken to avoid stretching the foam during installation. And if the gasket has a PSA backing, the adhesive layer can provide that stability. At Marian, we take pride in providing parts that are designed for manufacturing. We can package and provide your gasket in a presentation that makes it efficient and accurate for your assembly. This may include extended liners, pull tabs, halo liners, or liners with locating pinholes. Many gaskets can be provided kiss-cut on rolls for automatic or robotic placement. We'll work with your process engineers to find the most efficient presentation and package to aid in your assembly.
Another problem in gasket designs has to do with uneven compression of the gasket. If compression of the foam is imbalanced, the area of the gasket that's compressed the least can be susceptible to pressure leaks. Whenever possible, ensure even compression during installation. For example, tightening bolts in an alternating pattern can prevent uneven loads. When the enclosure design includes a hinged opening on one side, consider adding evenly spaced clamping forces around the non-hinged perimeter of the encasement to keep the compression even.
The last cause for gasket failures that we'll discuss today is related to insufficient venting in the enclosure. This is a topic we'll take a closer look at during a later blog and video. Many sealed enclosures that are IP rated for IP68, for example, will experience pressure changes in vacuum or pressure buildup within the enclosure. This can cause multiple problems for the device, including moisture and humidity. The changing pressures can cause seal deformation and leakage, and you guessed it, failure. Without proper venting, repeated expansion and contraction can stress the gasket too much and compromise the seal's integrity. You may need to include pressure equalizing vents in your enclosure to alleviate significant pressure changes. These vents help to equalize pressure by allowing air to pass, but with the proper venting materials, they won't permit the intrusion of water and moisture. As I mentioned, we'll discuss venting and venting materials in more detail in a later blog. In the meantime, if you have questions about vent construction and materials, give us a call or reach out online. We'll be happy to talk in more detail with you.
I think that's enough for today. Next time, we'll talk about the things you should consider when choosing a PSA for your enclosure seals and gaskets. This isn't always a necessary step, but it's good to be aware of in case your application requires it. Until next time, I'm Jimmy Budd.
And I'm still Phil Taylor. We'll see you next time.